First, though, we'll look at some of the basic design principles. There are a number of variables that must be considered in designing a windbreak. Essential physical characteristics to consider in the design process include orientation, spacing or density, height in relation to area protected, length, number of rows, and continuity. Appropriate species of trees and shrubs are also an important factor and will be considered later. Proper orientation is essential for effective protection. The ideal windbreak is oriented perpendicular to the prevailing wind direction. If the prevailing wind comes from only one direction, a single-leg windbreak can be used. It should be oriented within 45 degrees of being perpendicular. In some Pacific Island locations, winds may shift direction throughout the year. In these cases, multiple-leg windbreaks may be necessary, including placement on all 4 sides of your crop. Density and spacing is an important consideration. Ideally, windbreaks should have a wind permeability of 20 to 50%. That is, the windbreak should allow 20 to 50% of the wind to go through. This can be achieved by using the correct spacing for each species. Spacing should be such that as the trees or shrubs reach maturity, the crowns will touch or overlap slightly but not crowd. Windbreaks reduce wind speed for a distance of about 10 times their height. For example, a windbreak with trees 30 feet tall will protect a field area up to 300 feet downwind.
Besides this field being no-till and with a living ground cover, it's also protected by windbreak all the way around. 3 sides with the cane, and 1 side with the bamboo and other trees which are natural vegetation in this area. The cane is planted specifically to protect this field right here. No matter what crop is grown in here, that cane will protect that crop.
For larger fields, secondary wind strips may be necessary for adequate protection. For smaller areas, you may want to select smaller, lower-growing species to more efficiently utilize limited land area. Windbreaks should also be designed to prevent damaging winds from coming around the ends. This means that you should include additional length beyond the area or additional legs to prevent wind from whipping around the ends. Establish secondary windbreaks along the field sides if windbreak length cannot be extended beyond the field. The extension should generally be about 5 times the height of the windbreak beyond the area needing protection. Using the previous example, a 30-foot high windbreak should extend 150 feet on either side past the protected area. For specific design information, contact your local Natural Resources Conservation Service or Cooperative Extension agent. Wind protection must also be effective from the ground up. This may require 2 or more rows of plants. A row of tall trees will protect a larger area of the field. However, a smaller tree or shrub may be planted on one side to fill the spaces between the high canopies. A single-row windbreak can be effective only if the species chosen has uniform, wind-strong branches from the ground up. However, desirable species that fit this description are limited. Multiple row windbreaks may consist of 2 or more rows, preferably of varying species. Although this method takes up more space, it provides greater flexibility, reduces gaps, and allows harvestable species to be included within the windbreak. Multiple species bring greater diversity and reduce pests and diseases. It is important to maintain continuity within the windbreak. Any noticeable gaps can become wind tunnels that may actually accelerate the force of the wind. Openings within the windbreak for access purposes should be designed so that they are staggered or slanted or overlap to prevent wind from being funneled. Once you have taken into account the size of the area you want to protect and examined the prevailing wind directions, you can design and implement your windbreak.